Hi, today we will be discussing how to work with significant figures. Our goals for today are to determine how many significant figures a number contains and to perform operations of addition, subtraction, multiplication, and division and express the answer in the correct number of significant figures. Significant figures are also known as significant digits. They indicate the precision of a measurement. They include all digits known with certainty plus one estimated digit. If we measure to the indicated arrow, we can see that our arrow is between 1.6 and 1.7 centimeters. We can estimate the last digit such that our measurement would be 1.68 centimeters. In this example, we would have three significant figures. Here we have a graduated cylinder. To obtain the measurement, we are going to look to the bottom of the meniscus, which appears to be a little below 14 milliliters. We can estimate one digit and say that there is 13.9 milliliters of liquid in the graduated cylinder. In this example, we would again have three significant figures. Let's review a few rules for counting significant figures. Leading zeros are never significant. Whenever we have decimals like this and we have leading zeros, we can draw an arrow from the left to the right to the first non-zero number, and then everything to the right of that will be a significant figure. So here we would have two significant figures. For our second example, if we draw an arrow from the left to the right to the first non-zero number, then we have these four significant figures. Zeros between other digits are always significant. So here the zeros between 8 and 7 are significant. So here we would have 5 significant digits. This zero here would not be significant because it is not between other non-zero numbers. So here we would just have 4 significant digits. So zeros to the right of other digits and the decimal point are significant. So again, if you have a decimal point, if you just draw an arrow from the left to the right, then everything thereafter would be significant. So these 5 digits would be significant. Here again, since we have a number with a decimal point, if I draw my arrow from left to right and then count all my digits to the right, I would have 4 significant figures. If there is not a decimal point and the zeros are not between other digits, the zeros are not significant. So here, if you do not have a decimal point, if you draw your arrow from right to left to your first non-zero number, then everything to the left of that would be significant. So here 300 would have 1 significant figure. And then for 25,000, again, we don't have a decimal point there, so we could draw our arrow from the right to the left to the first non-zero number, and then we would have 2 significant figures. All non-zero digits are always significant. So for 125, all the digits would be significant, so we would have 3 significant figures there. For 7.643, all the digits are non-zero, so they would all be significant. We would have 4 significant figures in that number. In scientific notation, The significand, which is this part right here, contains the significant figures. So for 1.263 times 10 to the second, that would have 4 significant figures. And for 4.19 times 10 to the negative 7, that would have 3 significant figures. So here is a summary of all of our rules. But a quick way to check for significant figures is when a number does not have a decimal, draw an arrow from the right to the left until you get to the first non-zero digit, then all other digits to the left are significant. When the number does have a decimal, draw an arrow from the left to the right until you get to the first non-zero digit, then all other digits to the right are significant. Go ahead and pause the video and determine the number of significant figures in the following numbers. When adding or subtracting measurements with significant figures, the result will have the same number of decimal places as the measurement with the lowest number of decimal places. For example, if we add these numbers together, we will get 19.98342. However, notice that the lowest number of decimal places we have is 2 decimal places. So we only want to go out 2 decimal places. So we would write our answer as 19.98. If we subtract these two values, we get 27.589. Here our lowest decimal place is to the tenths place, so we would want our answer to be to the tenths place. Now here, since the digit to the right of the tenths place is 8, we would want to round up. So our answer would be 27.6. Go ahead and pause the video, and for the following problems, perform the indicated operation and express the answer with the correct number of significant figures. Check your answers and see how you did. When multiplying or dividing measurements with significant figures, the result will have the same number of significant figures as the measurement with the lowest number of significant figures. When we multiply these values together, we get 658.30688041. However, when we look at our factors, the factor with the lowest number of significant figures is the 1.72, which has 3 significant figures. So our answer can only have 3 significant figures. Therefore, our answer would be 658. Here, when we divide these two values, we get 1.213857, and it goes on and on. We see that our divisor has only 3 significant figures, so our answer will only have 3 significant figures. So our answer will be 1.21. Now go ahead and pause the video, perform the indicated operation, and express the answer with the correct number of significant figures. Check your work and see how you did. And I hope you did really, really well.